Hi everyone. Hope you can hear me. If not, raise your hands. And yeah, I'm Patricia. Really happy to be here talking about CI/CD security. And it's good to see so many people willingly, hopefully, here to geek out on CI/CD security. Disclaimer, I'm gonna say CI/CD a lot, but hopefully you won't be annoyed with that. So that's me. I'm a cloud security engineer, and a year or so ago, I managed to get myself into this project that was all around cloud tagging. So tagging your resources that you are doing via your Terraform deployments or even container images, labeling them. So I had one goal, or we had one goal in my company, and that goal was to tag assets with very specific keys and a set of allowed values. So I found myself, okay, how can I do this? How can I ensure that I guide users into using these keys and these values? That's when I was genuinely excited to find the concepts around policy as code and guardrails. And that picture is, honestly, is really accurate. I was so excited by when I was talking about these things, because you're telling me I can define a high-level policy in some sort of JSON format and then give it some configuration. Some engine comes out with a yay or nay, as in it's compliant or it's not compliant. I'm like, tell me more. There are many tools that do this. Open source ones, you have things like Open Policy Agent, and in our case, we were using Chekhov. Because for us, it was kind of a no-brainer. We already were using Chekhov by Bridge, Crew, Prisma Cloud. It's already in our pipelines. Let's go for it. And you think, okay, awesome, right? Well, slight issue there. We needed a little bit more than just the out-of-the-box policies, which meant it would be more resource, more time to put into this attempt to do policy as code. To be honest with you, I was like, okay, maybe it's not worth to invest the time here. And it's just too much work. We don't have the resources to do it. That changed when, when you find yourself with a free weekend and a kind of cool GitHub name, project name idea, a problem starts to sound more like an opportunity. And that's when Pack on Rails came into existence. Pack on Rails, nothing to do with Ruby on Rails. It stands for Policy as Code on Guardrails. I thought that was funny somehow. I have another one. It's called Pack on Lines. I'll leave it up to you to try to understand what that means. But essentially, you go to, I don't know, Sunday or something, and I got somewhat of a working minimal viable product. So I gave it some JSON, like that one, that said, oh, you need to use these keys and this set of allowed values. And then I was testing it, and it was kind of working. And you can see there, to test it, I was using the first line, which was essentially saying to Chekhov, which is the policy engine, do the standard out-of-the-box checks, but also use the Python code that I've developed to do these extra checks. I was happy. I was getting the results that I wanted. Close my laptop, go for a bike ride, because I done it. I'm happy to do it on Monday when I get to work. Well, I started to think, wait a second, these policies that I've just written in Python are going to be running in every single pipeline that I have, or that we have in our organization. And then I started to think, wait a second, what's that second line saying? It's saying I can similarly specify GitHub or any Git server URL to go and get some policies. Which would mean, well, you're essentially running someone else's code that someone has written in your own pipeline. And I started thinking slowly in this. Because I started thinking, no, it cannot be true, because I've written this, and I could have done whatever I would like with that Python code. So I decided to do some malicious checks. So one of the things that I did was, okay, I have arbitrary code execution from someone that pulls the checks that I've written, what else could I want to do? Well, I could try to just exfiltrate some data, for example, with Git, which was what I did. And now you're like, Patricia, that's not that interesting, because you just described essentially open source, because you're running someone else's code. And I agree with you. I would even go a step further and say, well, I just described anytime you are running someone else's code that you haven't thoroughly reviewed and that you're running in your machine. The solution here, to me, is not to stop using things that you haven't written yourself, because that's not very scalable, but it really made me start thinking about the security of the CI/CD platform. So whatever is running those checks, or whatever is running code that wasn't written by me, that thing will be accessing whatever that pipeline, for example, has access to. So that's what led me here. And this is kind of a long introduction to why am I here now? Why did I start to look into this more and more? So, in this talk, we're going to go over some definitions just to make sure we are all talking about the same thing. When I say, for example, CI/CD and CI/CD pipelines, I would ask if is anyone not familiar with CI/CD, but hopefully the definitions that we're going to go over will cover that. After the definitions, we're going to do some observations on based on those definitions and trying to puzzle together a few of them. And then I'll end with a proposal. That proposal won't solve all our problems, but hopefully it makes it a little bit more digestible. It has certainly helped me face some of the challenges. The first definition that I wanted to go over is on the screen, which is the CI/CD platform. What do I mean when I say CI/CD platform? It's fine if you disagree, but to me, in this talk, CI/CD platform or CI/CD system, whichever, is really anything that touches your CI/CD workflow. That means from the repo, the Git repo that you're potentially using, that is Azure repos, GitHub repos, Bitbucket, anything, to pipelines, things like Azure pipelines. I'm a bit biased towards Azure DevOps because that's what I use, but it could also be GitHub repos, GitHub Actions, or Jenkins pipelines, things like that. All the way to more towards the right side, things like Argo CD, Flux, that will play a part in this CI/CD ecosystem as well. I'm tempted to include things like binary repository managers. If you've heard of things like JFrog Artifactory or Nexus repositories, I would include them as well, or even things like container registries out there. That's one definition. The second definition, hopefully more interesting, pipeline. What's a pipeline? A pipeline, when I started to really look at what does it mean to be a pipeline, it's just a set of instructions. It's just saying that's kind of just pseudocode. Obviously, it's not YAML like what we would usually see in a pipeline definition file. But what that's saying is it's just something that tells you to run somewhere with some code as some user and potentially to use some sort of variables that are stored in this variable store, for example, or environments. But the core there is just that set of instructions, it's that recipe. Without the resources that make up, so that compute, that user, that repo, it's really nothing. You can't really access anything. There's even a poem. I'm not going to even try to read it, but it's to capture that essence. The last definition is around resources, CI/CD resources, and it's the things that I was talking about. It's that compute that you're using, it's that user that you're using, it's the repo, it's the environment or variable store that you're accessing. All of them, one way or another, point to something. And that something is an identity. they are pointing to a certain idea. More directly or a little bit more far-fetched, they kind of point to some kind of access into something you care about. For example, if we take compute, if you're using things like workload identity federation or some sort of access that is based on the machine you're working with, well, you're essentially getting access to the permissions that that machine that the machine has. With a user, if you're using certain things like service connections or certain credentials, you are assuming the privileges that that user has. That's your pipeline as well. If your pipeline is using that pipeline is going to have those permissions. Repo is a little bit more indirect. With repo, you can think of the current ways that you have to do for continuous deployment systems, where there are binaries essentially looking at your repos, and if there's any change to that repo, the changes are done in the runtime environment. So essentially, by messing with that repo, you can make changes to the live environment as well. And variable source, again, you're potentially storing their credentials, usernames, passwords, and those credentials will grant you access to some sort of identity, some sort of access, privilege. And that's what that line says, is the pipeline itself doesn't have privileges. The privileges are granted by the resources that it accesses. So, to put it all together, we have a pipeline. A pipeline accesses some resources which ultimately are just a proxy into an identity. And there's this book that I really like how the authors phrased it. So, identity native infrastructure access management. And their take is that identity as its core concept is really immutable and is not transferable. But you can't use that in a digital world. To use it in a digital world, you need to create some sort of data format for that identity. And in this case, their proposal is credentials. They're calling it credentials. So in a sense, a CI/CD resource that is accessed by the pipeline is just a credential. It's a proxy into an identity. And because a credential is essentially data, it is transferable and you can steal it. They do mention something that I really like, and I subscribe to that ideology, which is there's no such thing as identity theft. What you have is credential theft. And I really like that idea. Okay, we're done with definitions now. We're moving on to observations. And as I said, I'm a bit biased towards Azure DevOps. That's because I use it and it's all I always use. I am almost sure that you can adapt it to any other CI/CD platform or system that you might be using. Okay, start with the blue dot. The blue dot there represents just the high-level pipeline concept, the pipeline definition. So that's just the recipe. Let's call it the recipe. Now imagine you create a pipeline in whatever pipeline system you have, and then you run the pipeline. When you run the pipeline, you create a pipeline execution, the yellow dot. And if you press the button again, you're going to create another pipeline execution associated with the same pipeline definition that I have there. And now imagine you're about to click the button again to run, but you haven't quite clicked it yet. You have a potential pipeline execution. And in this case, it's associated with main, because you're in the main branch, if you're familiar with that. I have a video, this is what it looks like in Azure DevOps. I'm just creating a pipeline. I'm selecting the source repo, and I'm going to select the path to my YAML file. And that's it. Essentially, that's how you create a pipeline in Azure DevOps. And when I press run, I've just created a pipeline execution to that pipeline. Okay. If I create another branch, in this case I call it feature 197, I have another pipeline execution, another potential pipeline execution, because it's another branch, and it's just another potential version of that pipeline file. So what I can show you is here, in this version, I am changing the pipeline definition. I changed the pipeline definition, and then I'm just going to commit to a new branch. So I ended up having two versions of the same pipeline, but actually they can be as different as we want. Okay, we're done with the pipelines now. We're going to introduce the other concept, the concept of a resource. And this resource, if we remember, is just a proxy into an identity. To make it easier, we're going to say that this resource specifically is a variable group, which is a concept in Azure DevOps to store your variables, your usernames, your credentials, and any other variable you might want. After defining the resource, what we need to do so that our pipelines can access it is grant the pipeline access into that resource. So essentially, we're going to just draw a line saying, yeah, this pipeline has permission into this resource. And here, you can see that my pipeline is not running. And it's not running because it's waiting for me to grant it access. And I stopped at a very strategic point here in the video, because what it says, I don't know if you can read it, but ADO does let us know that once you allow access to this resource, this variable group that has some username and some credential to an identity that I really care about, my prod environment, for example, all the pipelines from then on will have access to that resource. And why am I slowing down here? Well, that means if I create another branch, and that branch has some kind of twist in the pipeline definition, it can still access the credentials that are in that resource, that red resource there. So now as the security side now, it might be like, oh, okay, that doesn't seem quite right, because what if I'm exfiltrating some sort of credentials with that pipeline definition? And that's kind of the point. That's kind of why it can be scary to think about these things. So, how does this look? I'm going to touch on two things for a starter. Approvals and branch protections. With the approvals, look, I've fallen for this trap, and I've seen other people falling for it. It's not even a trap. It's just you might be over-relying on controls that are not that rigid. And we'll see why I'm saying this. So what I have here is I have a pipeline, and it's a Terraform pipeline. If you've played with Terraform, loads of people do this, and 100% is something that I've done as well. Terraform plan, and then you have a stage for approval to see the plan. Is it good? Is it not good? And then you apply it. Okay, what if I am either not patient enough to get someone to approve it, or I'm a potentially malicious person? I can just go to the approval stage and just remove it, and then commit it to the main branch, and then run it again. But no one's going to stop me from doing that, I'd say, because what I can see is that I can save it. I'll save it, I'll commit it to the main branch, and when I run it again, I won't have that approval stage. Ta-da! No approval stage. And the thing is, it's quite evident that I removed the approval stage. You could do anything. This is just to exemplify, you can just mess with the pipeline definition file. I could have just said, you keep the approval stage, but I'm going to run whatever command I want before the approval stage. Because remember, pipelines, you're just essentially running arbitrary code. You're giving that possibility to users, which is good, in a controlled way. But now you say, Patricia, you won't be able to do that in our pipelines because we have branch protection rules. Okay, is that a challenge? Well, I'm going to add branch protection rules, and you'll see that I'm adding them. It's not that hard, at least in Azure DevOps. You just go there and you say, for the main branch, I'm going to say it's a protected branch, and I'm going to say, if you want to push to the main branch, you need certain users to approve it. And that's fine, except what are we really protecting with those branch approvals? Because if I go to the main branch and I remove again the approval stage, okay, I'm going to be blocked from pushing to the main branch, as we can see here. I am blocked, but what does that matter? Will I still be able to do everything else that I was doing in the main branch, but in some other branch? Because something that I'm doing now, I'm creating another branch, and then I'm executing the pipeline anyway. And once I execute it in the other branch, and I press run, no approval stage. Again, you do anything there. What does this mean? What can we do about this? Well, it's going to be always about layering controls, ensuring that the controls that you're applying are working together in order to meet whatever goal you want to achieve. Because what we've seen with the approval and the fact that you can just edit out approval stages from pipelines or manual validation. Well, first of all, you shouldn't be relying on controls that you can just edit out from your pipeline file. That's one. But when it comes to the branch approvals, more than thinking, I need to apply this branch protection rule to my main branch, you also need to ensure that whatever you're doing in that main branch, that I won't be able to do it from a non-protected branch. Else, okay, you're protecting the main branch, good for you. I can still use any branch that I create. And now you're telling me, okay, I'll make sure that my pipeline definitions are really strict, and I'll put them in some other repo, and you won't ever be able to touch them. That's fair. That's an approach. But then we have this possibility that we are including other things that we haven't written. We are using templates. We are using packages from other sources that we have no control over, so external to that pipeline definition file. And I'm going to exemplify this with two sort of use cases. The first one is about semantic versioning, and I really like to talk about this because it does mess with my brain a little bit, because the security person in me is saying, oh, we need to use hashes because that's the only way we can be sure we are using a specific version. If you work with containers and container versions, as a security people don't really like to use latest, because latest is always changing. You never know what's actually in the latest, pointing at latest, in the latest version. But who here uses hashes? I have rarely seen people using hashes. Usually, engineers and developers settle for a middle ground, semantic version. Things like, oh, this is version 1.0, 1.1, 1.2, 2. Those kinds of semantic version. The thing is, even that is I can overwrite it. So here, I'm being a good citizen. I'm using templates that have been built by a platform team, for example, and those templates are versioned, and I'm using version 1.0 from that repo that is in mind. But this works really with any kind of artifacts and versioning. And then I'm like, okay, if I am as an attacker, I go to the main branch and I change that version, and I change the repo, so the templates. These are the templates. And what I'm doing, I'm changing the latest template, and I'm adding a dragon because I thought that was cool. What we're going to see is that, okay, I am committing. An attacker, for example, was able to do some change to the template, but if I still go to the version 1.0, which is the version I am using in my pipeline, I still won't see any dragon. So that's cool. However, what happens if I go to the version 1.0 that exists there now, and I delete it, and I recreate it, but this time, when I recreate it, I will point at the dragon version. What do you think it will happen? Well, I'm going to see the dragon. Ta-da! Because someone has just recreated the tag. So, I've done this, right? I've done this in a non-malicious way. Even if it was malicious way, I wouldn't be saying it was malicious. But, it can happen that even if you're using version 1.0 and you think, oh, it's never going to change, it can change. Hashes are probably really the only way that you know what you're running in your pipeline. Okay, you're not saying, that's it. You're going to always point at the latest version, but I'm going to control really heavily how people access those templates or those versioning systems, so it won't be a problem. Still have another example for you, another use case, which is all about what are the tools you're using in your pipelines. Are you using Terraform? Are you using things like policy as code engines like Chekhov and OPA? Because what you can do with it, so Terraform has this really cool resource, which is called like the null resource, and it allows us to specify provisioners. And provisioners can be either, for example, local execution or remote execution. Remote execution is essentially saying, run these commands in a target machine. I haven't played too much with it. But I did play a little bit with the local execution, which is essentially, if you're running a pipeline that is running Terraform, local execution is going to make the Terraform execute commands on that runner that you have on the pipeline, the build agents, the compute that you have. So what you can do is something like that. Quite simply, remember how I started the talk, talking about Chekhov and how I used Python and Git to exfiltrate data? Well, here is the same concept, same basic concept, but using Terraform to run these commands, which are Git commands, to push data out to a random repo that I had created in big buckets. And I was able to exfiltrate the environment variables that pipeline runner had access to. So if you had access to production credentials, well, now I have access to them as well. There are other ways that you could do more clever ways you can do this. And Shelly Robin, she has a really cool talk that talks about things like DNS tunneling as well. So she used Terraform and OPA to exfiltrate data through protocols that you usually would not have blocked within your pipeline because it's DNS and everyone kind of needs DNS. Okay, but what can we do? What can we do about this? Well, one, access control. Access control to your pipeline definitions. That's obvious. But at the same time, you need to allow some development activity to be happening. Look, when I'm developing some sort of pipeline, I rarely get it right the first time. The first 10 times, it's just garbage. So if you're going to lock it down, you really need to think about the productivity side of it. Tag management, also really important. But again, you do need that flexibility for people to develop their own stuff. You always need some sort of SOC use cases or detection rules. So one detection rule that I thought about would be if you detect some kind of activity where someone deletes a tag and right after recreates that tag with the same name, something maybe you should investigate. Why would someone do that? Because it's supposed to have an incremental tag number. Again, investigate. Don't just say it's malicious, because it might not be. Like, I've done it before, as I said, and it was more of an operational decision. But maybe you should investigate. And again, it's that layering controls concept. We're all doomed. Or are we? Well, there's a bit of a proposal that has helped me a lot when thinking about this, not to get overwhelmed. And instead of looking at the pipelines themselves, I try to look at the resources that are being accessed. And by doing that, you are focusing on what really matters to you. If I don't care about this resource that is giving me access to a sandbox environment, maybe I'll leave it to the end to deal with. And I'm going to start with this really important production access credentials that are stored in some sort of variable group or service connection. So what I would say is, okay, one, you need an inventory collection, a list of CI/CD resources you have, and understand which ones are really important to you, so that you can prioritize, and so that you can also, as a group, because it's going to be a group, it's not going to be you single-handedly doing this, but you need to agree on what are the conditions of access that you are comfortable with. Say, this is not malicious access, and this is actually good access, and it's obeying all of the compliance and security and operational requirements you have. It could be things like business hours. If you know a certain critical service connection or variable group is only used from 10 a.m. to 12 p.m., well, maybe you can do some sort of access restriction based on the time. Or you can also have a service connection or a variable group that always must have an approval from someone to be used. And you apply that based on the resource itself, not on the pipeline, because I can just remove it from the pipeline. So you establish and you agree those conditions of access. And then, the easy part is just manage the CI/CD resources according to whatever conditions you have defined. This is TLDR. It's really all around focusing on the access that the pipeline has, instead of trying to run around to make every single pipeline secure. You can do that. I'm just saying, it has helped me a lot, just focusing on the actual resources that are being accessed. Because since I started the talk, probably you have 100 more pipelines that have been created, and it's really hard to keep track of them. So if you focus just on the resource, which might be used by those 100 pipelines, well, you only need to focus on securing one thing. This is the final slide. And it's really a disclaimer. I'm not saying you're doing anything wrong or everything wrong. It's really just to raise awareness for some things that, well, might get you off guard, or maybe you know about this and you are doing everything okay. Anyway, I hope it was helpful. And if I had to finish on any kind of statement, it would be, it is really, really hard to strike a balance between security and making it usable for developers and for engineers. Be reasonable, and focus on the outcome. And that's it. Thank you.
Thank you very much, Patricia. Are there any questions? We have time for some questions.
Great talk. How was it taken at your organization when you tried to push this thing? Did the developers give you any pushback, hard time?
Sorry, can you repeat that?
Did the developers, when you try to put this balance in terms of restrictions to various resources, how did you manage that?
We're still working for it, actually. So I haven't implemented it yet, but how we are managing to kind of get it into production is just to think about, let's focus on what really matters and then apply those conditions. It's not going to be taken lightly by any teams, because sometimes you just really need to do it, and it's not always malicious. It's also just in terms of from an operational point of view, you just need to get the work done. So you really need to be flexible and work. It's also a risk decision. And at the end, if everyone agrees the risk, you have to say, you know what? You're in charge. Security can govern that for you.
Hey there. Great talk. I've hit all these problems before, the sort of CI/CD, which are developer Wild Wests. I'm sure you've seen them too. The only environment I've seen which is secure against this is when the CI/CD tool itself is governed under Terraform or something like that, and it itself is change managed. Whereas if you have developers of privileged roles, they'll break versions, change CI/CDs, and you might as well give up at that point. Would you agree with that, or can you have developer having privileged access and secure this? Because I would argue you can't.
I'd say the privileged access, it's on those resources again, and then it might be, if you have approvals, for example, and you have more than just a couple of eyes looking into it, it's that shared responsibility, and maybe you have a senior person as well there to help you with that. But yeah, it's a hard one.
Any other questions?
Thanks, Patricia. So you were talking about controlling access to these resources. Now, in some organizations, there's a lot of those resources, and it's not clear to security people what controls should be put in place around them. I wonder if you've got any thinking around that.
I was saying I was a little bit biased towards Azure DevOps. I do use it a lot, and I do think that Azure DevOps gives you a way to protect those resources in a quite efficient manner, because it allows you to say to that service connection, to that variable group, to that agent pool, so that compute that you're using, every time you're accessing it, apply this rule, and that rule can be an approval, can be a that business hour restriction, can be things like calling an API, which gives you a lot of flexibility. So it's almost like having a conditional access on the resource itself, which would be something to do. How I would handle it is, if you're not greenfield, so if you have loads of resources, start by stopping for a second, and anything that is new goes through this process where you look at the resource and you work out, is this resource really important to me or not that much? And if it's really important, you start any new resource that is really important in its broad environment, you start adding certain conditions of access. And once you've got that life cycle managed for the new resources, you then start working on the resources that are there. and are you being used already? And eventually you'll get to some sort of eventual consistency there.
And any more questions? Right, if there are no more questions, then thank you very much to Patricia Rodriguez.